The James Webb Space Telescope has been investigating the faintest objects for answers about the universe. NASA's new eye above has been searching for stunning images of enormous stars, designs, and worlds. But in the end, something unexpected has been found, something so massive that it might shake the very foundation of everything we understand. It has scientists scratching their heads and assessing whether it could provoke the farthest limits of existence. Join us as we explore how the latest discoveries of the James Webb Space Telescope may destroy our comprehension of the universe as it existed when we explore the edge of the cosmos. We are talking about the observable universe, the visible universe that seems like a window through which we can look at the magnitude beyond the scope of what is known. It encompasses all that we can presently perceive, measure, and investigate using our telescopes and space probes. It's a collection of stars, galaxies, and heavenly bodies within our grasp of understanding. Regardless, the observable universe is only a portion of the whole universe. Think of it as a slice taken from a huge, enormous pie, one that we're able to study and comprehend, while the total size and shape of the universe at large remain a mystery. Scientists estimate the width of our observable bubble to be around 93 billion light-years. A light-year measures the distance that light, the fastest thing in the universe, travels in 1 year, about 5.88 trillion miles or 9.46 trillion kilometers. So when we discuss the breadth of the observable universe being 93 billion light-years, we're talking about a huge distance. The universe began to form 13.8 billion years ago in an impossibly strong impact. This event started what we call the Big Bang. Since that tremendous birth, the universe hasn't just been expanding, it's been accelerating in its expansion. Baffling forces such as the enigmatic dark energy appear to be increasing this speed, stretching the boundaries of the universe further and further apart. As the universe expanded, matter began to collaborate under the influence of gravity. This gravitational force joined particles, birthing stunning structures, stars, massive galaxies, and eventually planets like our own Earth. Picture the universe passing by as these colossal structures formed, evolving into the unique yet constantly growing oddities we see across the universe today. Despite its vast size, the universe is incredibly empty. If we reduced our entire solar system to the size of a quarter, the nearest star would still be about the length of 2 soccer fields away. This vastness extends even within our own Milky Way galaxy, which is just one among billions in the observable universe, giving us a sense of the sheer size of infinite space. Now you may ask, why can't we simply see everything that exists in the universe? There are several reasons. Most fundamentally, light, the fastest thing known, still takes time to travel through space. This means that when we look at distant objects, we are essentially studying the past. The farther an object is, the more time its light has taken to reach us. It's like looking through a vast time machine, unrolling the history of our universe as we observe galaxies millions or even billions of light-years away. The real universe is expanding. Imagine spots on the outer layer of an inflating balloon. Those spots move farther apart as the balloon rises. This same principle applies to galaxies in the universe. Like those spots, they are drifting apart as the fabric of space stretches. This expansion causes the light sent from distant objects to undergo a shift known as redshift. Essentially, the wavelengths of light stretch as the objects move away, shifting toward longer wavelengths, often appearing reddish in color. Given these factors, light's travel time, the expansion of space, and the ongoing progression of the universe, it's not surprising that we have not yet seen everything the universe has to offer. Even with our advanced telescopes and technology, our perspective is still limited by these key properties of the cosmos. The journey to grasp the possible edge, or limits, of the universe has captivated the minds of countless people across disciplines. While definitive answers remain elusive, 3 prominent theories have emerged, each offering intriguing perspectives on the propagation of infinite space. 1. The infinite expansion theory. This suggests that the universe expands forever, without an observable edge. This idea aligns with the cosmological principle, which states that the universe is isotropic, consistent in appearance from any vantage point. If this holds, it suggests there is no boundary and the universe expands infinitely in every direction. 2. The finite but unbounded theory. This proposes that the universe may be finite but lacks a clear edge. Instead, it may resemble a vast circle or warped space, much like Earth. In this scenario, if one were to travel forever in any direction, they would ultimately return to their starting point, much like circumnavigating the globe. 3. The multiverse hypothesis. This theory presents the idea that our universe is just one of many others. Imagine an infinite number of parallel universes, each possessing its own set of constants and properties. These universes may be entirely separate or possibly interconnected through complex systems, forming a vast and intricate multiverse. The James Webb Space Telescope, JWST, stands as a symbol of potential, illuminating the mysteries that lie at the vast origins of the universe. This incredible instrument has an unparalleled capacity to unravel the confusing past of our universe, allowing us to see much further than what was previously possible. A groundbreaking study published in the journal Nature revealed the JWST's discovery of 6 massive galaxies, dating back between 500 and 700 million years after the Big Bang. Astonishingly, these ancient galaxies are far larger than expected for their early existence, challenging prevailing theories of galaxy formation. Their development in the early universe is truly remarkable. What's extraordinary is the sophistication in these ancient systems. They contradict the assumption that galaxies form slowly over time. These massive galaxies exhibit a level of complexity comparable to our 13-billion-year-old Milky Way. Each of these titanic behemoths contains a total mass several times greater than our Sun. One galaxy may even have a mass up to 100 times that of our Sun, overshadowing the already enormous size of the Milky Way. The JWST's unmatched ability to explore hidden regions of the universe is based on its use of infrared light, creating a view opaque to the naked eye. This power enables the telescope to capture the faint emissions of ancient stars and galaxies, revealing remnants that have endured for billions of years. Essentially, the JWST acts as a time machine, pushing our vision back through the ages and offering a captivating glimpse into the universe as it appeared roughly 13.5 billion years ago. The continuous discovery of massive galaxies, eagerly nicknamed universe breakers, has revolutionized our understanding. It's like rewriting history, a stunning twist that challenges many of the models we previously established for early galaxies. At first, we believed galaxies formed from humble beginnings, small collections of stars and dust, evolving gradually over time. However, the universe began. As scientists examined the data, more questions began to emerge than answers. How could such enormous, complex galaxies exist so soon after the Big Bang? According to current models of cosmic evolution, galaxies of this size and maturity should have taken billions of years to form, yet here they were, already fully established just a few 100 million years into the universe's life. These findings push the boundaries of what we believe to be true. If such galaxies existed that early, then the processes that drive star and galaxy formation must have occurred at an accelerated pace, far quicker and more efficiently than previously thought. This raises the possibility that our current understanding of physics, time, and cosmic structure may be incomplete, or even fundamentally flawed. And this isn't the only revelation that JWST has brought to light. Beyond the massive galaxies, the telescope has also identified extremely faint and ancient stars, never before seen by human eyes. These stars, some of which may be among the first ever formed, provide rare glimpses into the cosmic dawn, the era when light first began to break through the darkness of the primordial universe. By studying the chemical composition and light signatures of these stars, scientists hope to better understand the earliest elements forged in the universe. These clues might help explain how hydrogen and helium, the first building blocks, led to the creation of more complex atoms, and eventually, the diversity of matter we observe today. But perhaps the most mind-bending discovery involves the structure of spacetime itself. The JWST has detected distortions in the fabric of space caused by massive gravitational fields, known as gravitational lensing. This phenomenon, predicted by Einstein's theory of general relativity, occurs when the gravity of a massive object, like a galaxy or black hole, bends and magnifies the light from objects behind it. In some cases, this effect has allowed astronomers to see galaxies that would otherwise be hidden, lying even farther back in time. These observations have opened a new window into the deep universe, exposing previously invisible pockets of ancient light, and hinting at even older galaxies that may still lie beyond the JWST's reach. Moreover, some of these gravitational lenses have revealed anomalies, unexpected patterns of light, warps, or missing mass. These irregularities might point toward unknown phenomena, such as the presence of dark matter structures, or even new physics that challenge the foundations of Einstein's theories. Could these be clues pointing to dimensions beyond our own? Are we on the brink of discovering that our universe is part of something even larger, more complex, and more mysterious? Some researchers now wonder, if our assumptions about early galaxy formation were wrong, what else might we be missing? Could the timeline of the universe itself be miscalculated? Could there have been an earlier cycle of existence, another universe before ours, leaving behind echoes that we are only now beginning to detect? These questions bring us to a humbling realization: the more we learn, the more we understand how much we don't know. The James Webb Space Telescope is not just a tool, it's a revolution. It is revealing a cosmos that is deeper, older, and stranger than we ever imagined. Each discovery breaks another boundary, pushing humanity closer to the ultimate truths of our existence. And while we may not yet have all the answers, we are now seeing farther and clearer than ever before, into the heart of the cosmos, and perhaps, into the heart of creation itself. Even with the power of the James Webb Space Telescope, most of it remains hidden. Vast swaths of the universe are still out of reach. The discoveries continue to alter our perception by providing a glimpse into the incredible wonders that lie just beyond our sight. The vastness of space continues to inspire and awe. But with every new observation, we are gradually putting together a more complex understanding of the universe's history and future. The James Webb Space Telescope is an instrument that can change our perspective on space, time, and the very nature of our existence. The JWST's discoveries extend beyond just new observations, they challenge the very foundation of modern cosmology. If these massive galaxies exist so early in the history of the universe, it forces us to rethink current models of galaxy formation. For decades, scientists have adhered to the idea that galaxies evolved gradually, beginning with small, dense clusters of gas and dust, slowly expanding over billions of years. The detection of these enormous galaxies, formed within the first few 100 million years after the Big Bang, presents a paradox that doesn't align with this slow evolution. This revelation raises new concerns about the nature of galaxy formation itself. How did such large, complex galaxies form so quickly? What happened after the universe was created? What forces were at play during those early epochs that allowed for the rapid formation of stars and the development of galaxies on such an enormous scale? These questions don't just challenge our current understanding of the beginning of the universe, they also push the boundaries of our knowledge of physics, particularly with regard to the conduct of dark matter and dark energy during the universe's formative years. The discoveries made by the James Webb Space Telescope have the capacity to fundamentally alter our understanding of the cosmos. The telescope's ability to observe distant and ancient galaxies has opened new doors for cosmologists, providing fresh insights into the early universe's structure and evolution. The JWST operates in the infrared spectrum, allowing it to peer deeper into space than ever before. This capability is important because it enables the telescope to observe galaxies that are so distant their light has been redshifted into wavelengths that are invisible to other telescopes. By capturing these faint signals, the JWST enables scientists to investigate the universe as it existed billions of years ago. One of the most fascinating aspects of JWST's findings is the detection of a few hundred galaxies that formed just a few million years after the Big Bang, during a period known as the Cosmic Dawn. These early galaxies seem to be more complicated than previously thought, with many exhibiting features that were assumed to develop over much longer periods. These galaxies are not only surprising because of their size but also because of their rapid star formation rates. These observations challenge the widely accepted model of galaxy formation, which suggests that, over time, galaxies gradually grew in size. Instead of billions of years, the JWST data indicates that it is possible for galaxies to have emerged in a significantly more dynamic and accelerated fashion than earlier models predicted. The question of how these massive galaxies formed so early in the universe's history has sparked intense debate. Some scientists propose that unique conditions in the very early universe could have led to rapid growth. Factors such as the density of matter in the early cosmos, the role of dark matter, and the influence of supermassive black holes might have contributed to the accelerated formation of these galaxies. Others suggest that our understanding of dark energy and its impact on the expansion of the universe may be incomplete, possibly influencing how structures in the universe developed. These questions are not only central to understanding galaxy formation but also to our overall understanding of the forces that shaped the universe in its infancy. The revelations brought forth by the JWST are also prompting scientists to re-evaluate our perspective on the evolution of stars. The early stages of star formation have traditionally been considered a gradual, slow process, but the JWST's ability to detect distant stars has revealed that some stars may have formed much more quickly than expected, possibly under conditions that we have yet to fully comprehend. This has implications for the way we think about the function of stellar populations in the formation of galaxies. The interaction between these stars and their ultimate demise in supernovae could have played a pivotal role in the enrichment of the universe with heavier elements. Furthermore, the discoveries of distant galaxies are not only a window into the past, they also raise questions about the future of the universe. As the JWST continues to unveil new and more detailed information, scientists will be better equipped to understand the ultimate fate of galaxies, stars, and the universe as a whole. The telescope's observations of distant galaxies and their interactions will provide crucial insights into how galaxies evolve and interact over cosmic timescales, shedding light on how the universe will continue to evolve over billions of years. With its advanced technology and unmatched reach, JWST stands as a tool that will continue to refine our understanding of the universe, challenging old theories and guiding new lines of inquiry for generations to come. As the James Webb Space Telescope continues its mission, it is not only reshaping our understanding of space but also inspiring new generations of scientists, astronomers, and curious minds alike. Its success is a testament to decades of innovation, international collaboration, and the relentless pursuit of knowledge. In the coming years, JWST is expected to explore exoplanets in greater detail, possibly identifying the chemical fingerprints of atmospheres that could support life. By analyzing the light that passes through these atmospheres, the telescope can detect elements like water vapor, methane, and even carbon dioxide, clues that might hint at habitability or biological processes. Such capabilities represent a monumental step toward answering one of humanity's most profound questions: are we alone in the universe? But beyond the search for life, the telescope's observations are also deepening our understanding of planetary systems, star formation, and the life cycles of stars. By peering into the dust-shrouded regions where stars are born, JWST offers unprecedented insight into the conditions that give rise to suns like our own and the planets that orbit them. In doing so, it helps us trace the cosmic origins of elements essential to life, like carbon, nitrogen, and oxygen, and the processes by which they are spread across galaxies by stellar winds, supernovae, and gravitational interactions. The James Webb Space Telescope is not merely an instrument, it is a bridge between past and future, mystery and understanding. It reminds us that every answer leads to new questions, and that the cosmos is far more intricate, more dynamic, and more beautiful than we ever imagined. In the vast silence of space, JWST speaks to us in light that has traveled billions of years to tell us stories of creation, transformation, and cosmic destiny. As we continue to interpret its messages, one thing becomes clear: the universe is not only more strange than we think, but more strange than we can think. And yet, with tools like JWST in our hands, we are inching closer to making the unknown just a little more known.